Okay, hello everyone, I'm Diefenbach. I'm presenting this work about a conversational agent to support citizens' interaction powered by Semantic AI, and I'm coming from the company called QAnswer. So maybe imagine you are going on a website and you have a chatbot and you ask some question and you get a response. And based on this response, you will make some decision. And we would like to show how this answer is in fact generated and how can we make the user understand what in fact generated this answer. So the talk is divided in 3 parts. In the first part, I'm going to show how we constructed a knowledge graph about the European Union, about information about the European Union. In the next step, I would like to show how we are answering questions on top of this knowledge graph. And in the final part, I'm going to show how we integrated this in a conversational agent. So how we constructed this knowledge graph. These are a list of projects of the Wikimedia Foundation. The most notable is Wikipedia, but also another very important one is Wikidata. In fact, Wikidata, if you count the number of edits of users per day, Wikidata has more edits than Wikipedia. So it's a very growing community. And it is mainly to collaboratively edit data, and we use the same infrastructure to set up the EU knowledge graph. So this is what it looks like, and it's accessible under this web page. And currently it contains, for example, information about European institutions. So here you see the article about Eurostat, how it is pronounced in the different languages. There are statements like it is a public agency, the place where it is located, the website, and so on. So all this structured data is there about European institutions, European countries, European capitals, DGs, which is a sort of ministries of the European Commission, and also projects financed by the European Union. For example, here we have a project in the Czech Republic, and we have, for example, the budget and where it took place, and a description, and so on. So what is the advantage of reusing this wiki infrastructure? And the advantages are, for example, that it is multilingual. So this is an important part for the Commission. So you can visualize, in fact, this data in any language you want. And, this is, well, now he put it in English. Okay, we saw it in French before, but anyway. Another important feature is that it can be queried. For example, here you get all projects financed by the European Commission in Denmark, according to what is inserted in the knowledge graph, and you can also go, and see the corresponding project. This would be a project in Denmark. And it can be edited by humans and by bots. So if you go here and you are registered, so it's a closed wiki, so only registered users can edit it, but in principle you can add some knowledge if you know it. You can also do this via bots, so via APIs. And a last feature, which is important in this decision-making process, okay, I forgot one, it scales. So Wikidata, which is hosted using this software, is currently one of the biggest existing knowledge graphs in the world, and it hosts 5 billion triples. And finally, what is very important is also that we track back provenance. So, for example, if you go to this article, first of all, you see who made all the edits. So you can keep track of which user added which knowledge, so where the knowledge comes from. And also you can add references, so you can point down where the data comes from. And now imagine you're asking a question on top of this data and you get a response. These two things are very important because you can always track down where this information or where this answer comes from. So this allows to explain the answer, in fact. Okay, so next step, we would like to answer questions on top of this. So when we think about answering automatically questions, we generally think about chatbots. And what is happening here is that traditional chatbot technology doesn't work perfectly for this use case. So there are classical chatbot technology uses intent detection, while we are using something which is called semantic parsing. So I would like to describe shortly the difference. If you have a normal chatbot and you have a question, I have a problem, my flight was delayed, then generally you predefine some intents, like my flight was delayed, cancel, overbooked, the luggage was lost. And answering this question is reduced to a classification problem. So you are trying to match this thing to one of these 4 classes. And then based on what is recognized, you do an action. In semantic parsing, you do something very different. So you analyze this question, what projects by DG Radio took place in Denmark, and you are trying to understand every part of the question, like for example Denmark, to map it to the concept of Denmark, projects by DG Radio, to map it to the concept of project by DG Radio, and out of these things that you recognize in the question, generate an interpretation of the question, and the answer is then the result of this thing. So you see that it's very different from what traditional intent detection is. So you can ask something like, who is the president of the European Commission? And you get something like this. Something very common also for semantic parsing or question answering over knowledge graph is that you get automatically contextual information. So generally in chatbots you get only the answer, while here you get, for example, external links, a description, photographs, and also summaries about the entities. So something else would be what is the capital of the EU, or who is the head of DG Connect, and so on. So very important is that also you get automatically explainability, because you are parsing the question, so you are really trying to understand it. So for example, this simple question was parsed and we produce many possible interpretations. And then we pick the first one. And the first one in this case would be Denmark/currency. So we give to the user also, we express to the user what the system understood, so that the system can, so that the user can in fact retrieve or understand what is going on and rely more or less on this question, on this answer. Okay, so finally we integrated this in a conversational agent. It is called Doris. It works in different languages. And so it starts like this. Hello, I'm Doris, assistant of the European Commission. I can help you on questions related to passenger rights and general questions about the EU. And something like, who is the... So here we get this answer that we saw also before, and this is retrieved by the knowledge graph by doing this semantic parsing thing. At the same time, we mix it with traditional chatbot technology. So if you ask something like, my flight was delayed. This is now classical intent detection. We recognize the intent, the flight was delayed, and we are starting to ask, okay, your flight was delayed, and sorry to hear that. I will now ask you a series of questions to see if you are entitled to get refunded by European laws. And then you say, was your flight starting or arriving in the EU? And you say it was within the EU, and then, okay, in this case, European law protects you, and you can go on and see what you can do. So, to conclude, I have shown how we constructed a knowledge graph of data about the EU. Importantly here is that we always keep track about where the data comes from and who edited it. I have shown how this data can be queried using semantic parsing and not a traditional a chatbot technology, which allows, for example, to get contextual information, to trust more the answer, and also to explain what was understood. And finally, I showed how we integrated this in a conversational agent. I would like to thank the Doris team at DG Connect, in particular Max de Wilde and Raphael Hubin. And that's it. If you have any questions, I'm happy to answer them.